Hi there everyone, Richard Williams here. It's the end of week 2, so it's amazing that 2 weeks have already gone past. Look, there's been some great discussions on the discussion boards there. It's pretty meaty content. If you haven't done anything in finance, and if you haven't done anything in economics as well, I'm not sure if there's anyone who's not done a finance or an economics unit in the past. There could even be some prerequisites here, so forgive me if I haven't done all my homework there, but it's pretty heavy content. But you're doing well, and there's some great discussion happening on the discussion board. If you're not getting involved in this discussion, you're missing out. It's really good going through these questions, tossing around the ideas, asking about how you've done a solution to a problem and whether it's there's any different takes on it. But look, these are my list here, right? I've got a bunch of stuff that I want to go through, and I'm going to try and keep it brief, and we can probably elaborate on some of the things I'm going to say in the discussion boards. But I just reiterate to start with that all of the solutions to the questions and problems in the text, the review in the text, so the questions and problems solutions, they are on Blackboard. There are review questions in the text which then have the answers directly after them, and there are also additional questions in the learning materials that I provide answers to at the end of each week. So make sure you're practicing these, but then checking your answers to make sure that you're actually on the right track, and that will really I guess just solidify what you know and what you need to review. Now, okay, so I'm just going to go through it one at a time. Now, the utility curve and the production possibility frontier. So that sort of theoretical economics stuff, that's a microeconomics concepts and models that being applied to finance in that 2-period perfect certainty model, and it's really good for you to understand that and how the utility curve and the production possibility frontier, or the PPC we sometimes call it, how they fit together and will predict the amount of investment. Now, it's a theoretical model. There's a few questions there about, how do I calculate these things? It's not about calculating them. It's about understanding what the model is telling us. So the key things there is the model is giving us an opportunity to predict the amount of investment and what will make that increase or decrease. And the other important points there are the curves. Okay, so the utility curve is curved because of the declining marginal rate of substitution. So what that's saying is the more I invest today and the less I consume today, because they're inversely proportional, the higher the interest rate I will require to invest more. So if I'm having to invest $100 at 10% out of a $1,000 paycheck, for example, I'm going to spend the other $900. Now, if I'm going to sacrifice another $100 out of my paycheck, I'm going to want 15 or 16%. I'm not going to do it for 10%. So that's the concept of the declining marginal rate of substitution. Now, there's another declining marginal rate of transformation, and that's for the production possibility frontier. Now, what that's saying is the more you invest, the less opportunities there are to invest. And you're going to pick the low-hanging fruit first, I guess, and then as you invest more and more and more, you're going to get not as good opportunities for investment, and the return will decrease. So that gives you a curve in the other direction. Review the text if you're a bit confused about that. But that's some of the discussion we've been having there on the discussion board, particularly with Kerry's questions. So thanks, Kerry, that was good. Mohammed, you've also posted, and that's there's some great questions there that you've raised. Now, you've spoken about using this formula: future value equals present value times 1 plus r to the power of n. Now, this formula, many of you will have picked up, is absolutely an essential formula for you to really understand what's going on. If you don't, review the text again, because that is the linchpin of finance. It is this concept of the time value of money, and that's what that formula tells you. And really, I think somewhere in the text it talks about there's really only three ideas in finance, and that's the time value of money, diversification, and arbitrage. That's the only three principles that we really need to consider. And this formula embodies the time value of money. And you will use this in all of your equations. And you'll use this in all of your problems, almost all of your problems related to time value of money. I really encourage you, when you're doing, first looking at a problem, don't necessarily think about how you can get to the answer. You can do all sorts of things with Excel and create tables and do all the calculations manually. First and foremost, think about your cash flows and how you're going to apply this formula. If it's related to the time value of money, you need to use this formula. You need to become very familiar with this formula, and that's how you'll get the marks in the exam, is by using this formula effectively. You've got to be able to rearrange it. You've got to understand what the future value and what the present value are when you're looking at a problem, and so you can substitute those numbers into that formula. And of course, I think a lot of your questions, Mohammed, were answered. Present value is one of the questions you asked about. That is, what is the money worth to us today? And this is the key question of everything that we've been looking at so far, is what is this money worth to us today? What is this $5,000 I'm going to get in the future worth to me now? $10,000 I'm going to get in the future. Whatever it is, whatever the interest rate, all those things are answering the question, what is this worth to me today? And we're going to talk about present value and capital budgeting in the future, and in future weeks. And Mohammed, you've talked about how do you manually calculate the interest rate where receipts and payments are not regular. Now that's an excellent question, and we will look at net present value in capital budgeting in later weeks. And what that allows us to do is to look at a whole project and all of the revenue streams and all of the expenditure and work out what the net present value is. You want to be able to go into a board of directors and say, this will put $200 or $200,000 or whatever the amount is, this will put those $200 of today's dollars in your pocket. That's what this project will do. That is meaningful to them. All the interest rates and all of the paybacks are meaningful, yes, payback period, but net present value is really the most meaningful thing. It's like pulling out your wallet and saying, I'm taking money out, I'm putting back money, or whatever it's doing today, in today's terms. That is what net present value tells you. Now, working out the effective interest rate is challenging. It's possible, but it's not. You won't need to do that for the most complex of circumstances. Follow along in the text and do the exercises that it tells you to do for working out the effective interest rate. But bear in mind that some of the projects will go beyond the complexity that you'll need to work out the effective interest rate or the internal rate of return, but you will work out the net present value, and that is easier to do. So bear that in mind. But Mohammed, your question will be answered in future weeks when we talk about capital budgeting, and I like the fact that you're thinking ahead and you're thinking about practical applications here. I always think that's fantastic to think laterally as you're studying, even if you haven't fully grasped everything that you're reading and learning at the moment. Having some lateral thinking in how this can apply in the real world is fantastic, and I think it really shows that you're actually applying yourself, and I think it makes it interesting. So look, keep that up. So I'm going to move along here. So Jeff, Lauren, Glenda, you have jumped into the discussion here and talked about some of those questions in the text. One of them was, so it was 5.1, 5.2, 5.3, 5.4. I'm going to let you all have a review of the solutions on Blackboard. If you can't find them, comment here. That's what they all do, isn't it? Comment here, yeah, down here. Where and ask the questions, and I'll point you in the right directions, because when you go through those solutions, you'll probably pick up where you might be going wrong, and you'll start to learn how this formula of future value equals present value times 1 plus r to the power of n, how it's used all the time, over and over and over and over again, and that is the basis for all of these calculations. So I'll let you have a look at this, but I will make a couple of, I'll let you have a look at the solutions and ask some specific questions if you're still not sure. But I will just make a couple of comments. Compounding interest, that's what this formula is, okay? So compounding interest, it's interest on interest, and Albert Einstein thought it was the 8th wonder of the world and all that sort of stuff. So that when you're actually calculating future value with this formula of FV equals PV times 1 plus r to the power of n, you are actually calculating compound interest, okay? So Lauren, you're already doing it, and you're getting the right answers there, and there's just a couple of areas that you'll pick up as soon as you look at the solutions, and you realise, oh, you know, I've got to apply it in that way. So good work, great stuff, posting it up there for people to comment on, and that's fantastic. And I'll just mention there also that Jeff's comments are very helpful, and particularly relating to the quarterly interest payments. So if it's quarterly payments, you just divide the interest rate by 4. So if you've got 8% annual interest rate, you divide that by 4, you get 2%, and that's per period, which is each period is a quarter, so that'll be 4 per year. So just bear that in mind. But the solutions to 5.4 are on page 163 of the text, so have a look there. Okay. That was group 3, by the way. I thought I'd just go over both groups for the one video, and you can see what the other group's doing, get a bit of a glimpse of that, and hopefully pick up some good things. Group 1. Okay, group 1, Ellen and Eva, you've gone over a few practical investment questions. Fantastic. Eva, you've brought up the rule of 72. Now that's an interesting one, and it's handy, because basically what you do is you say, intuitively we think, if I am getting paid 10% return on $100 in 10 years, I will get to $200. And of course it's wrong because of compound interest. So what you do is you say, well, 10% return, instead of dividing it into 100, you divide it into 72. So you actually say, if I'm getting paid 10% return on $100, I won't double my money in 10 years. I'll actually double my money in 72 divided by 10%, 7.2 years. Does that sort of make sense? Hopefully. It's kind of handy as a rule of thumb. It doesn't work when you get to very high or very low rates of interest, but typical rates around 5, 10, 15%. You're going to get very close to the right answer to work out how long it'll take to double your money. So in 7.2 years, you'll actually double your money at 10% interest. Hope that makes sense. And so, Chris, Natalie, and Ellen, so Corey, you posed that question there about saving for your car rego. Great example of consumer mathematics. These are the kind of types of questions that we come up with every day, and we think, well, how much money do I need to put aside to actually, yeah, have that available? And obviously the interest rates aren't high at the moment, but it's very, very useful thought. And Natalie, you and Ellen, like, that's fantastic use of the I presume you're using your payments function on your calculators. I don't have the Sharp calculator. In fact, I don't even have a financial calculator. I use Excel. But you guys have to worry about exams, okay? You can't take Excel into the exams. So use your calculators and get really good at them, because those functions will make your exam a lot quicker, and you'll get lots more marks if you're really good at using that Sharp calculator, or whatever financial calculator that you are using. Okay, so I'm going to have to wind this up because I think YouTube will cut me off at 15 minutes. But the salaries one, actually I'll post another one about the salaries. Okay,